Are we good? Are we ready? Yes, yes. We'll get started. We'll get started. So, good morning, everyone. My name is George Linares. I'm CMS Chief Technology Officer. So, welcome to this month's Tech Topics. I thought for sure today was June already, but it's now. We got one more day. But it is the end of May. So summer is here. So we have this session and then next session for Tech Topics, and they'll be taking a break for a couple of months. July, usually people on vacations, and we'll come back in September. But we still have May and then June. So I'm still getting in a little confused. So today is very exciting. It's all about AWS. It's about their framework and the services. I know there's a lot of questions out there. So AWS and the team here with the cloud team at CMS have a great presentation for everyone. Just one quick item. I know we're still getting emails for people that want to be part of the distribution list. If you can drop off your, there's two ways, right? We have a distribution list. You can drop off your business card to Angela in the front there, and then she'll add you to it. Or you can just follow us on Twitter, CMS Gov. And then we're always trying to put out all the different events that we have. That way you can follow us instead of us to you. But we're still using the distribution list. Okay? So with that, I'm going to turn it over to the team in GDIT. So who's going to be driving? I know there's a whole casting here, and I'm going to let the team introduce themselves. Okay?
Excellent. Thank you very much. So my name is Jamie Baker. I'm the sales manager on the AWS Health and Sciences team. I've been with AWS for about 4 years, running this team just starting this year. Previously, I was the Department of Energy and NASA account manager, so I had a lot of experience dealing with large-scale scientific workloads on the cloud. And I'll let Nate Rigola from GDIT introduce himself.
Good morning, Nate Rigola, GDIT. I'm principal architect on the AWS CCS work. Previous to that, I worked in private cloud, and before that, high-performance computing.
Wonderful. So you'll have to forgive my voice. I woke up about 2 o'clock in the morning with congested, and then I was like, oh, wonderful. I haven't had to present in quite some time, so it's good that I get the frog voice for you all. I saved it. In any event, so here's the agenda that we're going to work from today. So we're going to talk a little bit about specifically the virtual private cloud and the concepts around makeup. How do you cordon off a piece of AWS for CMS's exclusive use? We're going to go through some of the key concepts around security and networking that are involved within VPC. Then I'm going to ask you if you wouldn't mind once we reach that point, to hold your questions till we get them. We have some other subject matter experts who'd be able to field anything that's too technically deep. I'm happy to take anything, any questions that you don't feel are very, very deep technically. But again, I'm a sales manager, so use that appropriately. But at that point, we're going to have Nate come up and talk specifically about the CMS implementation of VPC as it relates to your actual networking architecture. So he'll go through a number of different slides, how the routing works, how the network architecture works, and then he's going to pass it back to me, and we'll go through security and compliance, different features and functionality there, and then kind of a high level, we'll walk through the various services that we have within AWS that are for your use, as well as some that are being kind of currently evaluated, so ones that you can test with. So without further ado, we'll jump into Amazon Virtual Private Cloud. So Amazon Virtual Private Cloud, if you can take a step back, so we launched our first service in AWS about 2008, which was our Amazon S3, which is our simple storage service, which was quickly followed by our virtual machine instances called EC2. Back in those days, AWS had a large swath of IP space that any developer could say, hey, I'd love to start up 10 virtual machines. AWS, give me some of your IP space to run these, and then I can build a scalable web architecture from that. As we started having more and more enterprises coming to us, it was very clear to us that folks didn't necessarily just want to have virtual machines running somewhere on the internet in Amazon's IP world. So we created the concept of virtual private cloud. And essentially what this is, it's a software-defined network that is made specifically available to you for your use. We have no visibility into this network, and it is 100% under your control. So you control all of the routing, firewall rules, everything. One of the, by default, these VPCs, when they're booted up, they don't have any internet connectivity. Everything from the ground up there is no kind of connectivity. You have to enable and open up any ports to this. So you can imagine, a black box that you are controlling from the ground zero of what kind of connectivity this has. So the big benefit that you get from using a VPC, again, is that control and the agility that you achieve with that. But also, you're able to bring your own private IP space into the cloud. So by doing that, you now have the ability to have, via virtual private networking, an area of AWS that looks and feels exactly as though it's down the hall in a data center here, right? So you have, if you can imagine, a virtual private network into a virtual data center, and all of those EC2 instances or virtual machines now can be under the same purview of any on-premises infrastructure you have from a management and visibility perspective. So that's really, really powerful because it allows you to have this elastic virtual data center at your fingertips that can scale out and scale back without actually having to do any hardware procurement, and you're only paying for what you consume. And so this is a really interesting kind of concept. If you can imagine in a traditional data center, when you have security and you have firewalls, traditionally you're kind of creating what you would see as this outside blue circle, right? So you're saying, I'm assuming everything inside my data center, I want to protect it from the outside world, but you don't really have all the visibility on what type of traffic is happening between your virtual machines. Or I want to be very granular as to this particular virtual machine or EC2 instance can only talk on this particular port to this database instance, for example. So what AWS allows you to do is we give you kind of, if you can imagine, this is like layers of an onion. Around every single EC2 instance, you've got on the outside basically cider blocks of route tables, which will control which is basically like virtual VLANs, if you're familiar with that term. Then the next layer in is network access control lists. So these are stateless firewalls that basically you can block on particular CIDR ranges of IP addresses. One layer inside of that is AWS Security Group policies. These are stateful security groups that are very specific to what type of traffic and what type of access people would actually have on that particular instance. And then even further down in the stack, you can have any other operating system level firewalls that you wanted to put in, or in packet inspection or intrusion detection systems. So you can imagine it's very, very different than what I described as kind of having a barbed wire fence around your network. You have very, very granular and specific control of all traffic and all ports that goes to every single instance. The other benefit here is that, and I'll go into a little bit more detail when I talk about security groups, but you can update your entire fleet of services just by making a policy change, which is also really, really powerful. But I'll go into details there. So when we talk about kind of how we enforce policy, basically the concept here is that even if somebody were to make a mistake and open up a particular port, you still have all those other layers of security, like network access control lists. You have the firewalls all the way out on the edge. But basically, the concept is that there is the least privilege policy. So in order for a packet to actually go through that entire stack, it has to meet all the criteria. If it does not, it will get dropped. So the concept is that you have basically this defense in depth where it's a deny unless there actually is a rule in place that will approve. So you can imagine things get kicked out as they're, and every single packet goes through this process, which is really, really, really powerful in that, that kind of layered stack like I showed you. So VPC terminology. So I talked a little bit about the different types of firewalls and security policies that you have. So at a very, very high level, the VPC subnet is a CIDR range that you designate. Anybody here who's kind of a networking expert is very familiar with kind of CIDR notation. But you are going to, when you create the VPC, you're going to say, I want this to be a private subnet with a 10.x.x, slash whatever. And you're going to designate that that is the IP address range that you're going to be launching your instances in within the VPC. You can, obviously, as we talked about, you can add additional security with network access control lists. More often than not, folks who are really developing in agile DevOps modes are not using NACLs anymore. They call them kind of a blunt axe, right? It's like it's a way of saying, I want to block these particular IP addresses, and I don't care, any other criteria that defines whether or not I would. It's just basically a very rigid way to define a network, and more often than not, people are leveraging these more flexible security group policies as opposed to NACLs. One interesting thing is that a VPC subnet, we haven't really talked about availability zones, but the concept is within every AWS region, we have different data centers within that region that are on different power supplies, floodplains, connected to different ISPs. So within a region, you can build a very, very highly resilient application just by sharing the load across these different data centers. A VPC subnet cannot bridge across multiple availability zones, so you could potentially have a single subnet within each availability zone and then load balance across them in that fashion. Again, because we are doing software-defined networking, there is really no concept of wire sniffing, like sniffing on the network for packets. There is no ARP or broadcast because, again, we are doing point-to-point sending of IP packets, and there is no concept of being able to just sit in promiscuous mode and look for traffic. It doesn't exist in this new paradigm. So here's an example of how kind of subnets would be built out. So you can imagine if you've got a /16 large IP address subnet, you could create multiple subnets and give them specifically for production, test, and dev, and development. The idea is here that you can easily give access to a particular subnet to a separate group of developers, and then and you can define that they only have access to the machines in those particular subnets. Trying to think of anything else here. There's an interesting, if anybody's really interested in how AWS does, how AWS does software-defined networking at scale, there's an interesting video. There's a link here. I'm sure that'll be fun to type into your, if you take this home, to type it in. But it's really interesting. It talks pretty in depth about how we do switching and routing in a VPC. But if you're interested in that, it would be a good thing to look at. So VPC is really reserved for things like your block storage arrays and your virtual machines or EC2 instances. But AWS, if you've ever looked at our kind of homepage, we have over 75 different services. And I'll talk more at the end about kind of some of those services that are available. But the idea is that not every one of those services can be made available directly inside your VPC. It can't be privately addressed, if you will, based on, for example, CMS's IP address scheme. So the idea is that within a VPC, if you can imagine, we call it kind of the lollipop model. You've got a closed-off portion of AWS that has a VPN back to your local infrastructure. They call that the lollipop, right? It's just got a single encrypted tunnel back, and you have only traffic goes in and out of across that VPN. So that's great if you have just like virtual machines and block store. But like, for example, Amazon S3 is a regional service. This is our object storage service that you can't get to directly from a VPC without having a gateway of some sort. So we have different gateways. So the virtual gateway, what I just described, is how you would terminate a VPN tunnel. So that basically gives you connectivity directly back to your local infrastructure. So we call it a private gateway. We also have an internet gateway, which you can put in place on your VPN, which is basically a route and a gateway directly to the internet. So if you had a public-facing subnet of your web application, you would have an internet gateway that would get you out to AWS's very, very highly connected infrastructure for all the ISPs of the world. And then we also have a third gateway, which is called VPC peering. It's only been around for about, I would say maybe 18 months or so. It's very, very popular, though, because this allows you to connect multiple VPCs directly, even if they're not in kind of the same IP address range. So this is powerful because, and we'll talk about it in a little bit, it gives you access to create really cool architectures where you wouldn't necessarily have to you wouldn't have to replicate all of your security services in every VPC that you want. For example, if you wanted to run Splunk or you wanted to run some other IDS or IPS system. Now you can do some really cool architectures where you have shared services directly inside these different VPCs, so they all communicate amongst each other, but you're very, very fine-grained controls over what type of traffic and what type of communication they can have. So VPC route tables. This is essentially the the router configuration for your VPC. For example, if I'm an EC2 instance or a virtual machine inside this VPC and I want to talk to other EC2 instances, those are my local host addresses. If I want to talk to, if I need to talk to GitHub to pull down, a patch, for example, I can be very specific as to how, if I am using an internet gateway to get outside of my VPC, or if there's an on-prem system across my virtual gateway where I need to, for example, communicate with an on-premises Oracle database to pull some information in, I can be very specific and set up those routes in a route table so that my EC2 instances know where to go to get connectivity based on the type of traffic that they're designated for. This is also really powerful because it allows you to be kind of elastic, and the service will expand and contract automatically based on how much traffic is flowing through it. Network access control list. I mentioned earlier. It's kind of a less frequently used method for controlling network traffic. It can be done. It is less flexible, if you will, but a lot of folks who have very specific uses for what type of traffic they need to basically segregate different subnets and IP addresses. It's an easy way to do it, but again, it does pull back from some of the flexibility that you would get by using some of the higher level security policies that we offer as well. And so the security groups is what I was just referring to, the security policies. So these are dynamic, these are stateful firewall security controls. These allow you to very, very easily propagate security policies to a fleet of EC2 instances that, again, allows for ingress and egress specific rules. So if you can imagine, you want to ensure that a fleet of EC2 instances does not speak over port 22 for SSH, for example. You can modify a security policy and it will get propagated throughout all of those EC2 instances. So it gives you a really fine-grained control way to modify all the type of traffic that each EC2 instance has. And then elastic network interfaces. So these, you can imagine back in the old days when you were dealing with physical infrastructure, this is the NIC card, right? The elastic or the network interface card that would be part of, for example, a blade server. The nice thing about ENIs is that within a VPC, those elastic network interfaces can be moved around within virtual machines. So, for example, if you had an EC2 instance that was having a problem and you wanted to fail over to another one, you could bring up the second EC2 instance and dynamically move that ENI over so that the communications to all your back-end systems stays the same. So it's really an interesting way that you can kind of maintain a high level of service availability, but also be able to expand and contract your infrastructure by keeping the same IP addresses as you move forward. And so when I talked a little bit about Amazon S3 being a regional service, a lot of our services, as I mentioned, are regional based, meaning that they're not specifically private addressable inside your virtual private cloud, your VPC. And so what we're doing, so a lot of our customers kind of had heartache over that because if you remember I talked about that lollipop model where there's no connectivity except back through a VPN tunnel back to your infrastructure here. If I was an EC2 instance in that VPC, in order for me to get to S3, even though it's sitting 3 racks away from it in the same data center, the traffic would have to come down through the VPC virtual private gateway, through the VPN, and then across CMS's backbone, through a TIC, out to AWS, because the regional service is not inside your VPC, right? So what we're doing, and a lot of customers had heartache over that because, again, it added to latency if you had an EC2 instance that wanted to pull from S3. But we also charge a higher rate to pull data out. We don't charge you anything to pull data from S3 into EC2, but we do if it's going S3 to the internet back through the data. So basically customers were really frustrated because it was poor performance, and because of their security rules that they had to have traffic go through the TIC. But again, they also were kind of getting hit with this additional fee for no reason. So what we've done is we've created these, what we're calling VPC endpoints. And these are, you can kind of think of them as scalable NAT instances that sit on the edge of your VPC that allow you to basically, I'll use S3 as an example. if you have a bucket, an S3 object storage bucket, you can basically mimic that has a private IP address inside your VPC. So it now, when your EC2 instance needs to get to S3, all you need to do is call that private IP address that basically replicates S3 being inside your VPC. So we're doing that with all these different services here. So simply, so SES, SNS, SQS, and I'll talk a little bit more about what those are a little bit later. But the idea is that now it prevents you from doing that, what we call the trombone effect, right? So having to come through your private network and then out to the internet. It allows us to project some of these services that are not VPC inherent services into your VPC, so they become private to you. Does that make sense? Okay, so here's kind of like a visual of what I just described. If you can imagine that endpoint now gets projected inside your VPC, and so your instances no longer have to traverse across a VPN and across your backbone. And so when I talked a little bit about the ability to do VPC peering, what that does, and I mentioned that it kind of opens up a lot of really interesting architectures. So what it allows you to do is create kind of these transitive VPC designs so that you're not having multiple VPCs that each are home run back to your data center or your infrastructure here. And in order to communicate to each other, again, not having to do that kind of trombone traffic, now the VPCs can communicate directly to each other. And as I mentioned, it allows you to have really interesting things like a shared services VPC where you would have like a network operations center, or you would have all of the log data from your EC2 instances pumped into a central repository. So you don't have to mimic that security stack in every single VPC. They can all feed relevant information to each other, and then you can have some of these kind of more flexible infrastructure designs. So I'm going to pause now for the kind of the first round of questions if anybody has any. We've got some AWS architects here, as well as Nate is very deep on AWS and specifically about how some of these features and functionalities might be implemented at CMS. Any questions? Yes.
So if I understand VPC, it's a software-defined network boundary. On page 5 of your presentation, you have said, run your instances on single-tenant hardware. So does it mean that VPC also comes with dedicated hardware for the tenant?
So that bullet specifically references we still have something that's called EC2 Classic, right? It doesn't sound very forward-leaning, but like some of our very, very early customers, like Netflix, the majority of their infrastructure was running in what we call EC2 Classic. So it was before we even developed the concept of VPC. We didn't have, if you're currently running on in EC2 Classic, you don't have the ability to do dedicated hardware tenancy. It's only available if you're running in VPC. If you went out right now and created an account and by default we force you into VPC now, you have to kind of opt out of it. So it's not maybe that bill wasn't added more confusion than anything else. But I guess the idea is that if you did have an account, a legacy account, you can't do single tenancy without using a VPC. Anything else before we dive into kind of the specific CMS architecture with Nate from GDIT? Nothing. All right, Nate, I'll pass it over.
Thank you. So Jamie provided the background of what are subnets, what are VPCs, virtual private clouds, or virtual data centers. So this shows one data center's view, obviously in production, and we'll cover it later. There are actually 3 data centers in what we call the V3 architecture. But this allows us to focus on one data center specifically. If you've been around CMS architecture, you'll recognize the 3 zone. So you see web subnets with servers labeled web, There's a web ELB or load balancer in front of those. There's an application subnet with servers labeled app and app ELB. There's a database subnet with instances or servers labeled DB and RDS for the relational database service of Amazon. You'll see a subnet that has a transitive router in it, which is blue. That's the Cisco router. And you'll see an outgoing presentation subnet, which holds a NAT gateway when those are used. And you'll see CMS routable IP space. So this is a prod. It's labeled prod CIDR. So this is representative of a production application VPC. Of course, CMS has production, implementation, dev, and test. The idea at CMS and in this architecture is that you keep the blast radius small, right? So you have a production virtual data center, you have an implementation virtual data center, and an application team might choose to have a dev and a test virtual data center. Of course, application teams can have multiple. There can be other variations where they want their own shared services, where they may have 2 or 3 dev or test environments, right, depending on their needs. All of that is CMS routable IP space. Over time, it became clear that sometimes applications changed, right? They became popular. Someone started out without CMS routable IP space and then said, oh, I want to connect to one of CMS's data centers. Then they had to re-IP. So in the V3 architecture, the whole cloud team made the decision of let's just make everything CMS routable, right? That way, if an application team's needs change, by default, they're able to connect to CMSnet if they later choose to do so. Next slide. What do the CMS subnets look like in production? So the idea of a virtual data center and the subnets is that it's kind of like a pizza store. You might want a small pizza, a medium pizza, a large pizza. You might want different toppings. So depending on your needs as an application team, you may need a different sized virtual data center. Obviously, the IP space is a finite resource, right? CMS routable IP space is not unlimited. So you want to assign a smaller IP range to a team that has small needs, and you want to assign a lot of IP space to a team that needs to dynamically scale and potentially might have hundreds or thousands of servers. So of course, the subnets here are, of course, we have the 3-zone subnets. We have the web or presentation tier, we have the application tier, we have the data tier. As I mentioned, there's 3 availability zones per region in the V3 architecture, so there are 3 subnets. As Jamie mentioned, a subnet is specific to a data center. So all of those subnets are private. They're using CMS routable IP space. The load balancers would bring in traffic from the internet if that application is internet facing. If it's CMS facing, then it's simply routed to CMSnet without the internet. See a DMZ, this is also the outgoing presentation subnet for the situations where there is outgoing internet access. So the NAT gateway lives here. It's labeled public because it has public IP space. The management subnet is for management interfaces on servers. The transitive subnet is for Cisco virtual routers. Security and transport subnets are labeled as optional. Depending on the application team's needs, these are provisioned or not provisioned, or can be that IP space can actually be repurposed for something else. An example of a security subnet would be a team-specific security tool. So let's, for instance, the team had a reason to run a specific, say, a virus scanning tool. They might stand up that virus scanning tool. It would use the security subnet, and it would use the management subnet. So that server would have 2 NICs, and since it's serving a security purpose, it would have a security NIC as well. The transport, of course, is for legacy data centers. So when you need access to a non-3-zone environment, typically teams stand up a reverse proxy here and do the natting to the transport VRF. From an application team perspective, a question might be, well, how does traffic actually reach my 3-zone servers from the internet? And it's important to note in this diagram, Akamai is depicted here. Akamai is not required or used in all applications. You could replace Akamai with another CDN or WAF. You could also route traffic directly into AWS and perform those functions where required within virtual appliances within AWS. This represents, I think, one of the most complex traffic flows, so that's why it's depicted here to give an indication of how you would integrate with a third-party CDN using AWS and CMS routable private IP space. So of course, in the top left, we have users, someone with a computer who's connected to the internet. If they're accessing a CMS service through Akamai, they're going to do HTTPS to Akamai. Akamai is going to redirect that traffic to a web zone load balancer. It's public facing. The team is going to configure that load balancer with security groups, right? Just because the only users that need to come in on that public IP space is Akamai. So they're going to whitelist Akamai. That means no one else is going to be able to reach that load balancer except the Akamai services. That traffic will flow through the web ELB in step 1. Step 2, within AWS, that traffic is going to leave the load balancer and enter a web server. If that web server is kind of the traditional 3-zone application, a 3-tier application, where it's going to reach out to an application server, step 3 is going to be next. The traffic is going to flow to an application zone load balancer. From there, that load balancer is going to pick an application zone server to service the request. Once the transaction is on that application zone server, if it needs data, it's going to reach out in step 4 to the data zone load balancer, which is private IP space, and then that load balancer is going to select a database server to respond to the request. So that's the typical 3-zone traffic flow from the internet through the zones. Of course, if you've looked at a lot of CMS architectures, you may be thinking, well, wait a minute, not every application has 3 zones. Some applications are just application zone services. They might be an API endpoint to servers and other data centers in the application zone, right? So in that case, you might not have a web zone because you're just providing an application zone service. If you're a data service, you might only exist in the data zone, right? Because you're only serving as a data store to other applications. So in that model, you would have the choice of whether you wanted this standard virtual private cloud or whether you wanted to have a new template that perhaps only included the data zone subnets. You would therefore conserve IP space and use a sort of an appropriately sized VPC. So those are the types of choices that application teams have when they work with their business owners and TRB and decide what their architecture looks like. And transitive routing is mentioned at a high level in the Transit VPC. This has really enabled CMS to scale to a very large enterprise environment with a large number of VPCs, shared services, and broad access to CMSnet. So what you see depicted here is 3 virtual private clouds. The idea referenced was that you have something like Splunk that needs to be shared among many application teams, right? Due to the infrastructure cost and labor cost of operating tools like that, they need to be highly available, right, in a production environment. So it's often cheaper to run those as a centralized shared service rather than building those out and duplicating those shared services. So on the left is representative of a shared service VPC. We've omitted all the details of the subnets. The idea of this is to explain the concept of transitive routing, and we'll use that later to show the CMS architecture. So on the left, we have a shared service VPC. There are instances which would, for example, be a Splunk servers. There's Cisco CSR virtual routers. In this simple diagram, there's 2 availability zones. Of course, in production, there's 3. This is simplified. There's a peer. So Jamie mentioned peers as a way to connect virtual private clouds together. So there's a peer to what's called the hopping VPC. On the other side of the hopping VPC are more peers. The idea that you have multiple applications that want to send their logs to Splunk. In this case, the peering limit is 100 peers per VPC. So this is depicting that there'll be 99 applications peered to the hopping VPC. And on the shared service peer, we'll only use 1 peer. So through this idea of the overlay network and transitive routing, we'll be able to connect more than 100 applications to the shared service. If we relied on direct peers to the shared service, we would eventually reach the limit of 100, right? And then the question would be, do you build a second sort of Splunk environment and aggregate the data, or do you find a way to have a single shared service environment? For the overall cost, it was decided that a single shared service environment was best. There wasn't a need to duplicate a lot of the shared service tools, and there was plenty of scalability left in the architecture of those shared service tools if just we could find a way to connect more applications to it. So transitive routing, in essence, is similar to a VPN, right? It's an overlay network. It relies on the fact that there's connectivity between the shared service VPC on the left to the hopping VPC in the middle. And then the hopping VPC in the middle is peered to the application VPCs on the right. So the VPC on the right, a sample application VPC, is allowed to send traffic to the hopping VPC in the middle, and the hopping VPC is allowed to send traffic to the shared service VPC on the left. But the way VPC networking works is that the application VPC on the right is not allowed to route transitively through the hopping VPC in the middle to get its traffic to the shared service VPC. However, Jamie pointed out, AWS is not like actively trying to dig into your encapsulated packets, right, and figure out what's happening. So if you build an overlay network from the VPC on the right to the hopping VPC, and from the hopping VPC to the shared service VPC, on that overlay network, you essentially have what's equivalent to a VPN, and you can transitively route traffic from your application VPCs to the shared service VPCs. So green is the representative of which portions of the traffic is encapsulated. The black line shows the traffic that's unencapsulated. So this is important because the application teams don't have to do anything special, right? They don't know that their traffic is being sent in an overlay network. Of course, if they run a trace route, they'll know that there are some hops there and there's some IP space they might not recognize. That's the only indication they have that the traffic is flowing through an overlay network. That's actually great from the application team's perspective, right? Because they don't want to keep track of NATed IP addresses or anything like that. This is using CMS routable IP space on the application side and CMS routable IP space on the shared service side. So it behaves exactly the same way, whether it's directly peered or whether it's connected through an overlay network. You want to access a server, with an IP address of 10.0.0.1, you simply make that, you put that IP address in as your destination, and the traffic reaches it. If you build this and you convince yourself that it works, then there's another conceptual step that you can take. And you can say, wait a minute, there's an overlay network and there's hops. The traffic, it's routing, right? So the traffic doesn't know how many hops are in the middle. You can put the idea of that you can have multiple hopping VPCs in the middle, right? Just like your internet provider can have multiple routers on the way, to transport your CMS VPN back to CMS's VPN endpoint. We can do the same thing here, and obviously the same routing principles apply. Of course, the cost of this is increased latency, right? Every time you add a hopping VPC, you're going to add a small amount of latency because the router has to process those packets, and there's another logical distance that the packets have to travel. But in practice, that latency is quite minimal. So this enables us to connect multiple shared services and build sort of arbitrary hierarchies of transitive routing. So this means that CMS can have thousands of applications connected to a common shared services, whether those shared services are security and monitoring tools like Splunk, or whether it's access to something like CMSnet or the VPN for the CMS AWS environment. This next slide shows a redacted version of the CMS AWS architecture. On the right, we see a zoomed out version of an application VPC, a production VPC. There are 15 subnets depicted here, the 3-zone subnets, the transitive subnets holding the blue Cisco virtual routers, and the outgoing DMZ, or presentation zone subnets holding the NAT gateways. The other sort of supporting subnets are just omitted from the diagram. If we zoomed in, or you can see the red there from the web zone. So what this is indicating is how we're doing VRF separation for traffic. So the idea, of course, is that you don't want web zone servers communicating to database servers in another data center. Right? Web zone servers are supposed to communicate with web zone servers. Application servers are supposed to communicate with application zone servers. So how this works is that the router says, okay, I'm just going to advertise the subnets, the web subnets into the web VRFs, and the application subnets into the app VRFs. And those colored lines depict that red is web zone traffic, green is application zone traffic, and yellow is data zone traffic. So data zone will stay in the production data zone if it's a production virtual data center. Of course, if it's a non-production data center, there are non-production networks. In the middle is the hopping VPCs. So the lower hopping VPC is called the production hopping VPC. An application, any production application, or at least the first 99 of them, would be connected to the first production hopping VPC. When there's number 100 production application VPC, it would be connected to a second production hopping VPC. From that production hopping VPC, on the left you can see there's connectivity to the enterprise shared services, which holds things like Splunk. Internally, it looks very similar to the other VPCs. And north of the production hopping VPC, you can see something called the CMSnet VPC. That is another hopping VPC, and it handles overlay networks back to CMSnet. So this is the idea that you can chain the hopping VPCs together. you can access CMSnet through that hopping VPC labeled CMSnet. And so from the application team's perspective, their VPC is peered to production hopping, and once they're peered to production hopping, they have access to Splunk, and they have access to all the CMS networks through that single connection point. So you might look at this diagram and say, does CMS start here? And the answer is no. I mean, as initial, obviously, peers are scalable, right? They have high bandwidth scalability, and they were used. Direct BGP peering into the VPCs was used. So, for example, if you had two VRFs, you needed app zone connectivity and data zone connectivity, you had two sets of redundant BGP peers. You had a BGP peer pair for app zone and a BGP peer for data zone. So over time, what ended up happening was, of course, those BGP peers had to be created by people, and they were on physical routers. The other side, the physical router side, was on the physical routers, and the AWS side was in AWS. Of course, the more VPCs you create, the more IP space you consume of CMS routable IP space, right? It's just the natural thing that's going to happen if the IP space is unique. And the shared service VPCs have limits in terms of the number of route table entries you can have in them. So all this added up at a very similar time to this idea that there's a lot of virtual resources being exhausted, and the process to stand up, for example, CMSnet connectivity was painful from a process perspective. Why does it take, why are we involving multiple teams and people touching physical routers to scale something in the cloud? It doesn't seem like a very good cloud story. So at CMS's scale, it became apparent that something as sort of an enterprise-wide solution needed to be developed to scale to sort of the next level of growth. And out of that came the V3 architecture. And I think OIT and Office Communications and the cloud governance team and TRB deserve a lot of credit for embracing this long-term approach here, that this wasn't a quick Band-Aid. This was, let's figure out something that will last for a couple years so the architecture doesn't change in a month, after the Band-Aid doesn't work anymore. So this was a very scalable architecture to solve a number of those problems, to conserve CMS IP space, ensure that all of the application VPCs could be connected to the shared services and CMSnet. If you take major applications like Enterprise Portal, right, their goal is to be connected to everyone because they serve a shared service purpose within the CMS application framework. And so access to shared services and all of CMSnet was a key part of enabling them to do that. So I think time, and I obviously am a bit biased, but I think time has proven that CMS made a good choice with this V3 architecture, and it continues to support the growth that's been occurring in the number of VPCs in the AWS environment. Are there questions on the CMS specific implementation piece?
So on slide 22, you depict the three-zone architecture, and you show a data zone with numerous databases in it, and you also show a connection to S3. So you can talk a little bit about how people are using S3, how much data they're storing in the data zone versus S3 and that sort of thing.
Sure, I can address some of it here and then maybe some of it offline, just because this is being recorded, and there's a limit to how much sensitive information we can share on the recording. So it's really application team dependent. There are a number of application teams using VPC endpoints that Jamie talked about, which is private access to S3. It really depends on the architecture, right? Whether their use case is best suited to object storage or relational databases, or a non-relational database where they would build on EC2 instances. And in essence, it's dependent on their conversations with TRB and the business owner, how, if, for example, it's completely possible to build a system where you access S3 over the private IP space from servers in the data zone, right? If you're processing data and you want to keep that in the data zone, it's possible to do that. If you have data that's more public in nature and you're less concerned about it, then you work right with your business owner to figure out where that data belongs in a relational database, how you treat that. But in all cases, you should still be following the three-zone architecture in terms of what is the input. If you're servicing another data center, then you can do data zone to data zone. If you have a proxy server in the application zone, then that may be the way that you're accessing another data center. Does that?
So there's no sort of rule of thumb of when you get to a certain size data, you better be putting it over in S3 to be more efficient, or like size trade-offs, or is it primarily a relational versus non-relational kind of a discussion?
I do think it's more about the nuance of whether the data is suited for relational database and sort of database drivers searching the data and database queries versus, do you have something like object storage, Flickr or Facebook photos is a great example, I think, of a use case of object storage. So you have images that you want to store, and when your system is going to display the images, you need to build a metadata index around where those images are stored, right? What is their path to get to the pictures? So you put all the pictures on object storage, and then you have another system that tracks, which folder location essentially those pictures are in. And so that's a sort of a good use case of object storage, where putting a bunch of images into a relational database is possible, right? You can put binary data into a relational database, but it seems less well suited to that because it's really hard to scale out relational databases if you have petabytes of data, where Amazon is handling the scalability of the object storage for you, and if there's more requests for specific pictures, they're just going to scale that on the back end.
Got it. Okay, great, thank you.
Any other questions on the CMS implementation? Great. I'll pass it back.
Thank you, Nate. You get froggy again. So now we're going to talk a little bit about security and compliance before kind of diving into some of the other AWS services that are kind of outside the VPC. I don't know. Has anybody ever seen this slide before? This slide's been around for a long time, right? Because back in the early days when we started kind of having conversations with NIST and FedRAMP was being designed, we had to kind of let everybody know that we couldn't be responsible for security from the razor wire outside the building all the way up through the operating system and everything else. There's a point at which we have no more visibility or control into your infrastructure, and so we have to have kind of this delineation of AWS is responsible for the security of the cloud, of the infrastructure, up to and including the hypervisor on the physical hardware inside the data centers. But at that point, we have no control over what type of operating system you're putting on those machines, whether they're being patched, whether you're following best practices, whether you have security policies that leave these servers with port 80 open to the world. That is above anything that we can control. So we call this a shared security model, meaning we give you a huge suite of tools that you can leverage to make the most lockdown service possible, but a lot of it is in your control. So from that perspective, there are many things that we give you the tools again. You can implement however much of it you want to, but this really kind of shows that there is a demarcation point with which you take over primary ownership of and responsibility for the security of your data and your application. And so just kind of a smattering of these tools. Not every one of these, and so we kind of had a walkthrough a week or so ago, and so some of these services are not currently part of the, what do we call it? The SCA process. So some of them are not some of them are not currently available to be used, but this is just to show you that we have a very large investment in various security tools that can be implemented by you. So on the networking side, we've talked extensively about virtual private cloud. We also have a service that is a web application firewall, and a new service that we launched called Shield, which is a managed DDoS service. On the encryption side of the house, we have things like a key management service, which is a service that we manage on your behalf, but you essentially own access and control the keys, but we manage the keying and the within the AWS infrastructure that you have. And we also have another appliance that you can lease from us called a hardware HSM, which is 100% locked down. We don't have any access to it once you take ownership of it. So that is for really our most sensitive customers, Department of Defense and the like, where they don't trust that we have a managed service that would manage keys on their behalf. They want to manage and maintain literally a physical appliance that they're the only ones who have access to it. So in those situations, they kind of sign up for, if they lose their own key, there's nothing we can do to help you, right? So it can go all the way to that side. And then on the majority of our services, we offer the ability to just turn on server-side encryption. So for example, for S3, you can have us do FIPS validated and AES 256 encryption on your behalf for your data that's sitting in your buckets. So it's a really, really nice feature where you don't have to worry about kind of maintaining and doing all that cryptography yourself. You can do it as a managed service, and we will do that type of encryption on your behalf. Identity and access management. So IAM is really so the security policies is what can talk to what, and then IAM is really kind of the federation of your users' accessibility privileges and how that gets mapped into AWS for what types of calls can employee XYZ actually make into an AWS service. So IAM is a really, really powerful tool. I think it's unique from an AWS perspective amongst all the other cloud providers who are kind of trying to enter into this space. The amount of time and money that we put into making IAM a really robust and scalable service is kind of unparalleled. So I think a lot of folks, when they really dive into the power that you can get, both with security policies, but also married with IAM roles, you can literally say, I want John to be able to have access to these 3 objects within this S3 bucket from 11 to 12 every Tuesday. That's the only time I ever want John to have that. And so you can create something that granular. You can imagine how hard that would be in a traditional network to create a policy or a role like that. But those are the kind of the examples that you can do in the cloud of having very, very fine-grained access control and security policies. We support federation with your on-premises Active Directory or whatever else you're using via SAML. And we also have the ability to run and manage. We have a managed Active Directory service that you can run directly within AWS. And then from a compliance perspective, we have 2 services. So CloudWatch is essentially a service. It's kind of you can think of it as a triggering service. So you can have it monitor your EC2 instances or your databases looking for specific metrics. For example, my database is running at 90% utilization on the CPU, or 75% of my network traffic. Those CloudWatch metrics can then trigger other things to happen, for example, right? So if you've got, you can imagine, obviously you all live it, open enrollment, right? So like CloudWatch can be the metric that can spin up other EC2 instances if you have millions of people coming in, where you were only having, a few thousand the day before, right? So CloudWatch metrics, you can monitor specific parts of your AWS infrastructure and then do other things based on that data. And then CloudTrail is really, really powerful. Essentially it is the metadata that comes out of the AWS services. So every API call that's made to an AWS service, or every time an individual reaches in or starts a service, all of that data is logged. And so CloudTrail is our service that would pump into, for example, Splunk, right? So this is the log aggregation service that can kind of go into your BI tools to get a better holistic view of security and compliance, things like that. So I won't go through and read this, but kind of just an idea of some of the best practices that have been recommended by working with GDIT and your various cloud control groups. I don't know if there's anything specific I should call out on there, other than you can read through that at your leisure. And so HHS was AWS's kind of first partner to work with us to get our FedRAMP ATO with the PMO down in DC. And so we have a list of services now that have been through a third-party attestation, so a 3PAO audit. The FedRAMP PMO takes that data and then grants an authorization to operate for specific services where they have validated that AWS's controls are mapped into the FISMA moderate or FISMA high kind of baseline version of NIST. And so for those services that have not yet been through a full FedRAMP ATO, there's a process internal to CMS to validate whether or not the risk acceptance is possible for the particular application or use case that you have. So again, I'm not going to go through in detail that, because you can read as well as I can. But the idea is that if there's a particular service that you want to use and you notice that it's not part of kind of the pre-approved list, there is a method to go in, make a request. I can give you a perfect example of and I worked on this when I was working with NASA. They were doing they were creating a new web-facing portal for all of their rich multimedia content, right? So this is like the original Apollo cockpit audio recordings and stuff that's been sitting in basements at various NASA centers all around the country. And so they wanted to kind of have like a Shutterstock version where the public can come and type in the word Mars and have all of the best, right? As opposed to knowing you got to go to JPL and look for this particular website to find that. The idea was we have a service called Elastic Transcoder. It's a service that literally you push us a video and we will create high, medium, low res versions. We can create thumbnails. Basically you pay like pennies on the hour for a service that will just do this. You don't have to think about, I have to load an EC2 instance, I have to get this version of application, I have to patch it. This is just write one simple line of code. Every time a video hits an S3 bucket, create a Windows version, iPhone version, blah blah blah. And so they really wanted to use this because it was a huge cost savings, and so they went through a similar process and said, listen, the data's low. We understand the controls. It's built on EC2, which is already a FedRAMP service. So that's kind of an example of how this process could potentially be used. More often than not, it's when you're dealing with data that's not on the high side, where they really want to understand the controls and make sure that they're vetted appropriately. So kind of a high level of some of the additional AWS services. Some of these will have a red phrase underneath which says under SCA. My understanding is that we typically have either a SOC or an ISO audit done on them, whether they're like, for example, Lambda is actually in the FedRAMP ATO process right now. There must be some sort of use case where somebody said, we really want to use Lambda, so once that happens, then it goes through that process on the slide before, and then it gets kind of under SCA once it's started there. So EC2, I've talked a lot about it. It's our virtual machines in the cloud. Physical hardware inside our data centers that is married up with some version of operating system, which we call an Amazon machine image, and so that becomes your EC2 instance. We also have a managed container service, which we call ECS, which is EC2 Container Service. So anybody who's familiar with Docker, this is a container service which we manage all of the underlying infrastructure for. So you're only responsible for your container images, and we will automatically expand and contract all of the underlying infrastructure and make sure that that service stays up for you. You only need to worry about your containers. This is really popular for folks who want to take advantage of new technologies, but they may have like a really old legacy application that's just too cost prohibitive to kind of factor to run in the cloud. You can zip it up into a container and then put it into like the ECS service and then have it run without having all those dependencies break, because it's kind of in its own little bubble, but it's running on next generation infrastructure. So it's kind of cool. Lambda, which I just mentioned, Lambda is a service which you can, I kind of just think of it as a massive pool of compute that doesn't really have an operating system, but it will execute snippets of code on your behalf so that you can run completely serverless architectures. A good example I kind of talked about with that elastic transcoding example that I talked about from NASA. You can, if you had, a piece of JavaScript that was less than 500K, is that right? Is that kind of the max that we have right now for executable? You can create extremely flexible microservices such that a good example is I've got an S3 bucket. Every time somebody uploads a photo to that S3 bucket, when a new object hits via that CloudWatch, which I talked about, you could have a Lambda function kick off and say create 3 different thumbnails of it, create different resolutions, and then turn off. And this is billed by like the microsecond, right? So I have many customers that say, we use a ton of Lambda every single month, but I can't actually get it to charge me because we only charge you after you've done like 1 million executions or something. But it's a really cool service, and a lot of folks, you can imagine in this day and age that everyone's always very concerned about security, and like what is the threat vector on the fact that I've got a Windows 2012 server that hasn't been patched in a while, or God forbid, an XP machine, where people are starting to exploit some of these things that aren't getting patched. In this new paradigm, there is no surface vector, right? These things start and stop in less than a fraction of a second. So the whole idea is that as these systems start to become more decoupled and down to their kind of, their base elements, you no longer really have that, you don't have to worry about operating systems and things like that, because you're really down to just the code level, and you're down to executing snippets of code based on event triggers. So it's really cool. Lambda is I think is going to be revolutionary. A lot of people are using a lot of like the mapping agencies. They are just completely getting out of the business of running EC2 with, and managing operating systems and things like that. And then auto-scaling is a kind of an inherent feature that people think about when they think of moving to the cloud. So this is essentially a feature that allows you to expand and contract the amount, the fleet of EC2 instances that you have in a traditional architecture, right? So if you've got, we talked about open enrollment as a good example, you have a load balancer sitting in front of EC2, and then the EC2 fleet can expand and contract, can auto scale based on criteria that you determine is appropriate. For example, CPU utilization, networking throughput, database utilization. So I'll jump to networking services, VPC. I'm not going to talk any more about VPC. AWS Direct Connect, and I understand that it is in use at CMS. So AWS Direct Connect is a way for you to create a private network into AWS. So you're not running a VPN across the internet and terminating into a VPC. You can actually go to one of our colo partners like Equinix or CoreSite, where AWS has backbone routers inside these facilities, and you can do a fiber optic cross connect from one of your leased lines directly into AWS. So you can get it in fractions of a gig so like a 500 meg link, all the way up to 10 gigs. And then you can do multiple 10 gigs and then do load balancing across them. So we have customers who have 100 gigabit direct connects from their on-prem infrastructure directly into AWS. So this is a way for you to, a lot of people like kind of view it differently. So our regions are so highly connected to the world. A lot of people think that direct connect is just an added expense that's not necessary because we are because the throughput into our, I mean, literally it's like multi-terabits of connectivity. So a lot of people don't have a need for this. Others who want to do more specific things, for example, like providing their own quality of service, and they just need to know that there's not going to be, their bandwidth's not going to be impacted by, some massive upload that's taking place that you can't control over over our public exchanges. You guys have access to it. It's dedicated fixed bandwidth that is available to you. Yes. What is the direct connect pipes at?
Probably address that offline, but I can give you that information. Yes, it's both ways, and it's interconnected to the overlay networks to maintain the VRF separation. So essentially, Direct Connect provides
specific things, for example, like providing their own quality of service, and they just need to know that there's not going to be, their bandwidth's not going to be impacted by, some massive upload that's taking place that you can't control over over our public exchanges. You guys have access to it. It's dedicated fixed bandwidth that is available to you. Yes. What is the direct connect pipes at?
Probably address that offline, but I can give you that information. Yes, it's both ways, and it's interconnected to the overlay networks to maintain the VRF separation. So essentially, Direct Connect provides.
I think that kind of goes without saying. It's the ability to do. It kind of works hand in hand with our auto scaling, but to automatically share the load across multiple EC2 instances and load balance to ensure that not all traffic is heading to a single service. So it allows you to have failover across regions, but it also allows you to expand and contrast based on throughput need. And so we've got a number of different flavors of storage. We talked a little bit about S3. I think I probably just assumed that people knew what that was. You may be walking into shark-infested waters here. We had an S3 issue about a month ago or 6 weeks ago down in our Northern Virginia region here. But S3 is it really is kind of it's storage for the internet. It is the largest contiguous storage array on the planet. It has kind of become the ground truth for many companies as to where all of their data lives. It's an object store, so it's got a RESTful API. So each object that you put into S3 has a URL associated with it. So you can build very, very highly scalable applications. And back to the question earlier about when do you go with like a database storage system versus S3. You can imagine. So the connectivity that S3 has, it scales. You can consider it infinite because it will scale automatically on your behalf. So if you've got 5 petabytes of data and you've got 100 servers hitting it, and you can hit it in parallel, the service will automatically scale to support that throughput that you need. Whereas you will get into some bottlenecks and constraints if you're talking about trying to push that through a single 1 or 10 gigabit network interface card on a relational database. So extremely fast, extremely durable. We have 11 nines of durability, which means, I don't even want to use the term, but it's like we'll lose a single object every 20,000 years or something, because every single object is triple replicated across 3 availability zones within the region. And so that's kind of enough about S3. Elastic Block Store, EBS, is what you would be considered like an NSF mountable hard drive for an EC2 instance. So here's where you would keep your operating system, any other ancillary applications that you would need as part of your EC2. So typically, when folks boot up an EC2 instance, they will associate an EBS volume to it. It's very similar to like a network attached storage, and so that you can kind of consider those to be hand in hand. Glacier is a service that's which is an archiving service, which has the same level of durability as S3, 11 nines, but we do have SLAs around how quickly we can get the data back to you. So it's the Glacier service is about, I'm trying to remember from a cost perspective. I probably shouldn't even talk about cost because I know that, yeah. But it's extremely cheap, and you do have like a 1 to 3 hour window where we can make the data available back to you. But it's used predominantly for deep archive. A typical model would be, a person puts an object into S3, and you can set up what we call lifecycle policies. So, for example, if an object stays in S3 for 90 days, I want you to automatically migrate it into Glacier. If it stays in Glacier for 2 years without somebody touching it, delete it, right? So you can set up these policies that move data through their life cycle. An elastic file storage, so this is a shared file storage system that we have. So many legacy applications have shared file systems. It was a service that we didn't, it was really a deficiency that we had. We did not have a shared file system available. We do now. It stayed in beta for the majority of last year, and having customers beat it up for a while. But it is now available, and it's GA from AWS. It is under SCA, so it's going through the FedRAMP process concurrently with the SCA process internally at CMS. So you'll have to double check as to whether or not your application could leverage it if you had the need for a share file system. We have a number of database services as well. RDS, and so these are really, like I mentioned a little bit ago, kind of creating these higher level services where customers don't want to be in certain types of business anymore, right? And I think that, unless you are a tried and true DBA, those resources are getting more and more expensive from a personnel perspective, and they're getting harder to find, and they're very specialized. We take that away from you, right? So we will, for different versions, so for Postgres and Oracle and SQL Server and MySQL, we will manage the relational database infrastructure for you. You're only responsible for your data and your table schemas. So we will take care of all the patching in the back end and do all of the administrivia that you want to get out of the business of doing, and let you just focus on dealing with your data. So RDS is an extremely, extremely popular service that we have. And then so a couple of services which are in that SCA process currently. DynamoDB is a scalable NoSQL database. So it's tabular, I think is the phrase that you use. But the idea is that it's very, very good for streaming data, and it's very, very good for data that does not have that doesn't need to be locked into kind of an SQL type of infrastructure. So Dynamo, there are a lot of different use cases. Our essays, if you have interest in that, can give you more information. And then we also have, for anybody who wants to run Elasticache, which is kind of it's a brand name of a service that you can get. We named it the same thing, which is not, I don't know, it's always been confusing to me, but we have a managed Elasticache service that you can consume as well. And then Redshift is a petabyte scale BI service, which is very similar to RDS in that it's kind of a managed database. But the nice thing is that this feature brings kind of data warehousing capabilities to even small businesses, where before these are multi-million-dollar investments just for the underlying infrastructure. Again, this is something, a data warehouse that as a service that can be consumed by the hour. So we have analytics services as well. So one under SCA, the Elasticsearch. That was not the one we had before. No, that was Elasticache. The one I want to talk about is the Elastic MapReduce. So anybody here who's ever kind of build and run and maintain a MapReduce cluster probably is more hardened because of it. It's very, very difficult to do. Again, we're taking that heavy lifting away from you, allowing you to just focus on your data, and you can consume an EMR cluster for doing Hadoop types of jobs. And we have a number of different services and flavors of our EMR service that you can use. We have 3 different messaging services. It looks like all 3 are available for use, not under your SCA process. So we've got a queuing service that kind of is you can think of it as a system that will allow you to build these kind of decoupled services, such that the output of one application feeds into the queue, which will then queue up and then pull into the next service. So you can create some interesting architectures just by using a simple queuing service. Simple notification service. You can these are small things to really even kind of think about, but they're nice because you no longer have to say, oh, I'm going to build a server and send notifications either via pager or email or whatever based on events that happen. So SNS is a great way for this to be kind of a trigger for other things. A good example is that would be that that S3 to Lambda thing that I talked about. That could be a perfect use case for, hey, have a rule that's in SNS that if a new object appears in an S3 bucket, execute these other, kick off these other services. So you can build some really interesting architectures with this. And then SES, simple email service, kind of self-explanatory. It's a managed email service for doing. We actually have a lot of customers who use SES that want to do, send out emails and just have that as kind of a managed service for them. Talked a bit about CloudWatch already and CloudTrail. I will talk a little bit about CloudFormation. Kind of one of the things that when I was sitting over here, was thinking about, I kind of wish that I had, when I was talking about VPC, one of the things that I think is really, really powerful about VPC, and I'll talk about CloudFormation and how it relates, is your data center is really just code, right? It's everything about how your infrastructure is laid out and your VPC architecture. It's kind of defined as an application now, or just a bunch of code that can actually build that infrastructure and replicate it. So it's great to be able to say, okay, I've got my VPC architecture design. So GDIT uses this extensively when they talk about the 3-tier architecture. So they'll get it to where they want it. They can freeze it in time, and using CloudFormation, they can create a template of that environment. So then when the next application owner comes in and says, hey, I want to reference 3-tier architecture, here are what are my needs, they can plug that in, modify this JSON template, and then they can spin up a virtual data center that's already got all the connectivity in place. And so CloudFormation is the JSON instantiation of virtual infrastructure. So it's really, really powerful because you can kind of have a data center as a file and then put like a gold image on it and store it away. So pretty powerful stuff. So this one, it looks like the only one that's kind of fully vetted and approved right now is IAM. I talked about that being kind of the roles that you and permissions that you give to users and services. But we've also got a number of other services which are under evaluation now. I'm not going to go through all of them, but if there's any in particular of interest, feel free when we wrap up in a second to ask about them, and I'll have one of our essays address them. But I think I kind of touched on all of these at some point throughout the talk. Oh, and that was the last one. So maybe that's a good opportunity to, I can move that back if we want to leave this here. So that kind of concludes what we had in store for today. Please feel free, any questions, we have folks who can go fairly deep, or we'll be happy to stay up here for a while afterwards if you want to have kind of one-on-one sessions. So with that, thanks.
I know there was a lot in here, so hopefully you guys were able to take it all in. I know I was trying to. So a couple of things, though, that he mentioned, and I want to make sure that, so you know that, as you can see, there's a lot of velocity by which AWS is releasing services. We do have a process on how to accept new services as they become available and based on project needs. So that's one thing, working with a CISO that we have in place. Also, I know S3, one of the things that I'm trying to change is really how to come up with technical guidance in a way that can be reaching out to projects before you mix it into the TRA. As you know, the TRA, the Technical Reference Architecture, is meant to be the overall technical guidance for all teams, for all technical aspects that we have, including the cloud. So one of the new things that you'll see from us, especially S3 is one of those services that is being used in a number of multiple ways, beyond what it is beyond just storage. It's just the URL aspect of it. I think there's a lot of demand for it on how to make this data, especially when you want to disseminate data to external entities. So we're trying to sort of create some guidance, so trying to minimize the risks to CMS, working with the CISO and the technical and the TRB in a way that all projects can use without adding burden or moving away on how S3 was architected. So you'll see those in the form of TRB technical spotlights, and those be coming out. It'll be like a one-pager or two max. And what we want to tell you is this is how we're going to use S3 within CMS. And then those will be incorporated in the TRA, but I'm trying to be more agile or iterative, if you will, in the way we come up with guidance. And this is based on the demand that we see from project teams. As they come to the TRB, there's new ways to trying to use the services, so we're trying to take it all in and making sure that we're not creating any vulnerabilities from a CMS perspective. And that's our key. But at the same time, we know the power and the value that these services provide. So we want to make sure that we maximize their use as well. So that's one of them. We are looking into the, I know the ARS 3.0 when it comes to encryption. So that's part of it also that we're working on with the CISO, and let you know how S3 comes in. We are working with the cloud team and AWS as well, so you know more about that as well. What else? I got a couple of things in here. And also, all the information that we're putting out here is going to be available in Zone. So everything is being tweeted out, so the tweets are out there, and I know there's tons of tweets that come out of cms.gov, but you can bring them together using the hashtag CMS Converge, and you'll see all the technical tweets that are coming out from this sort of forum. So you can bring them all together. There's the access on how to get into Zone. You do have to register. So all these documents are going to be posted there that you can access them. We still need to know who's coming in and getting the information just from our own records. But for the most part, we're trying to be as transparent as we can possibly be. General questions, anyone? Good. Is this working? Being transparent, the technical guidance, there will be more? Yes, there's a question right here.
Make a comment here. So I appreciate Jamie going through this. I apologize for not announcing it earlier on. I'm Bob Spitz. I support Nate on the CCS program where we deliver AWS for CMS. But just wanted to point, Jamie went through a lot of the services that AWS provides. I'm sure a lot of light bulbs were going off of, hey, I can use that here, I can use that there. But I did want to clarify that not all of those are used or approved for CMS use. So if you have a question specific to which ones are available today versus which ones are going through the process or need to go through the process, The CMS Zone website has a distributed list, and I think the internal SharePoint site for CMS for the cloud team has a distributed list also. So that could be sort of your starting point of what's approved for use at CMS versus what needs to go through some type of a risk acceptance process. Thank you.
Yeah, and definitely contact the CMS Cloud Operations. They are the team working in the day-to-day aspects of the AWS implementation. Yes, sir.
Yeah, I have a question. Traditional proposals, you would have ODCs for hardware and software and networking, et cetera. For AWS resources, if you're proposing, how would you price something like that or figure out how big that is? Is that conversations with GDIT, the business leaders? How does that go?
I'm looking for my friends from OAGM. But Patrick, won't you come up because this is, there was a question about the pricing.
Right. So my name is Patrick Quajou. I'm the team lead for the cloud team and DevOps at CMS. So for the costing for what it costs to host an application at CMS, you would engage our team, the CMS cloud team, and we have a process which includes a questionnaire that asks technical questions on what your architecture would look like. And those come in, we do an IGCE and come up with the costing model for that, and work through that process.
But I think he's referring to new contracts that are on the street that are coming in. I know there is a pricing, and unfortunately our friends from contracts are not here, but for what I understand, we'll confirm this, is there is the AWS, there's public pricing in terms of the cost, and we can use those as a way to be included in your estimates as you're trying to price things. I think what Patrick just was referring to is once the contract gets awarded, we work internally with the teams in here to come up with the more specific aspects of it.
Right, that's a separate engagement with the
Correct.
business process, business owner, and CMS directly. It's not incumbent upon the software development team to pick up those ODC costs for hosting. Does that make sense?
It would be incorrect to say AWS is government furnished equipment.
That's correct, yes. There is a price to it, yes. It's consumption-based, but there is a price to it. Any other questions? So, thank you. Thank you very much. So our next session is going to be in June 22nd. It's going to be about Splunk and the enterprise portal. A couple of things about Splunk, just so everybody knows. CMS is doing a lot about coming up with DevOps guidance. What does it really mean? There's been a couple of documents, there's a couple of artifacts in Zone already about what we mean by DevOps. What we're working on next is coming up with a tool chain architecture type guidance for everyone. It means, everybody has seen the Gartner Infinity diagram plan create. So what we want to do is provide more details around that. I've always said that CMS is technology agnostic to some extent, meaning we're not going to dictate exactly what the program needs, what's being proposed, and so forth. But we do have a specific requirements we want you to meet, especially when it comes to DevOps and you're building and creating and releasing so fast. We are going to tell you exactly what we're looking for. In which platform you use to sort of release, you want to use Jenkins, you want to use Ansible, whichever platform you want to use, as long as those templates that you use or the pipelines follow and have those requirements is what we're looking for, more so. So we're trying to sort of make it easier for those developers and proposals when you feel comfortable with one platform versus another one when it comes to DevOps. Splunk is one of those tools that will be named, meaning it is required by CMS. You cannot be substituted. And there will be tools like that as well. And this is one of them. From a security perspective, it's been around for many, many years. And what we're doing today is expanding the footprint, going from security and now expanding it more from an application monitoring perspective. So it's another valuable service. Yes, it is consumption-based still. Like everything else, there's no freebies here, but at least we have the model by which project teams can leverage, and you'll learn more about Splunk at the next session. So, but I wanted to let you know that we're doing a number of things and trying to make sure that this information gets to you. I mean, we understand that technology is moving so fast, and we're trying to catch up and come up with a way to capture that without slowing it down, but at the same time making sure that you know what it means to CMS more so, because we cannot use those technologies as they are on private industry. There's a few things that we have to be accounted for, you know, federal regulations, policies, and so forth. And we want to be very mindful about those. Any general questions? No? Yes, we'll make this available in Zone as well, yes. Anything else, anyone? No? Thank you, and I'll see you next month.